All right, so we're going to program this algorithm to play a number guessing game with the user. The user is given 10 chances to guess a 4-digit number. If they get any of the digits correct in a guess, then the program will output the number of digits correct and the sum of those digits. So it is good to read your specifications once or twice over. Make sure we're understanding what we need to write. Okay? And then we'll write our algorithm first. So we could write our algorithm in a separate document, but a lot of times what I'll do is I'll write our algorithm as comments on the top of my program. So I'm going to go ahead and start Eclipse. Remember, you can make an algorithm with a flow chart or with steps. Today we're going to do it with steps, just writing out the steps. Okay. And you guys will turn this in at the end, so I do want you to follow along with me, and we'll go slow, okay? That way everybody kind of gets it. I think there's worth in following along sometimes. So open up Eclipse and then make a new class, and we can call it Number Guessing Game. Now the rule is, remember to name your class with an uppercase letter. So remember to name your classes with uppercase letters. And then you can check mark public static void main string arg, so it'll write this for you, but remember what that looks like, right? So it'll make our new file, of course. And then we can put our name, and we could put the date, because that's what we're always do. Yes? 3, 9, 3, 16. Is it the period 3, 9, or with dashes? Yeah, you can do dashes. I've just gotten used to putting periods because, I don't know, I just do. I guess when I name files, I use the dots, and so now I just use the dots. It doesn't matter how you put it, actually. And just so, you know, on that test, they showed you different ways to make comments, and maybe I should start doing different ways to make comments. Remember that you can make a comment with a slash and a star, and sometimes they put another star next to it, but you really just need a slash and a star to begin with. And then you end your comment with a star and a slash, so then you can have a multi-line comment. And what some people do sometimes, so remember that this is the beginning of your comment and that's the end of your comment. Some people will extend this out and make them stars like that, because you can't do any kind of highlighting. Okay. And then what they'll do is they'll put a slash here and then put a bunch of stars right here. So that it kind of, you know, differentiates this section a little bit. But remember that the comment part is just the slash and the star, and then the star and the slash. You could put a space there if you wanted to. Note if I put it together, it does turn blue because it turns into what's called a Java doc comment. A Java doc comment is a slash and a star and a star. And we haven't done Java docs, but if you wanted it to be blue, just put a slash, a star, and a star. Okay. But it translates, what it does is when it makes Java docs, it actually makes those HTML API pages for you when you put these kind of comments in. Okay. If you're interested in that, I can show you. But all right. So let's write our algorithm. So remember, we're kind of following the methodology. We start with the input and output. Start with your input, figure out your output, and then figure out your steps, which is kind of a good methodology to start an algorithm. So looking at our specifications, we can figure out what our input should be. Okay. So what's our input? Yeah, it's a 4-digit number. They're given 10 guesses, but our input will be a 4-digit number from the user. Okay, so that's what our input's going to be. So we'll say our 4-digit number from the user. We can even put from the user here. We're not getting it from a file or anything like that. We're getting it from our user. And then what's our output? And you look at your specifications to figure out what your output is. And we do have a couple outputs, actually. Okay. So our first output, if they get the number correct, we'll tell them they're a winner. So if they guess the 4-digit number, we tell them they're a winner. So that could be one of our outputs. If they guess the number, we output the winner. Okay, right? So if they guess the 4-digit number, meaning that 4 digits are all correct with our secret num, then we say, hey, you're a winner. Okay. If they don't, if they guess incorrectly, then we look at our specifications to figure out what our output should be. So if they get any of the digits correct in a guess, then the program will output the number of digits correct and the sum of those digits. Okay. So I could even just copy and paste that. I don't feel like writing that out, but that's what our output's going to be. Okay. So your text won't be as large as mine, but I do kind of like to format this a little bit so it fits on my screen. If they get any of the digits correct in a guess, then the program is going to output the number of digits correct and the sum of those digits. And everyone understands what that means, right? So we do have to make sure we know what that means. So let's say our secret num this is going to record kind of weird, but let's say our secret number was 1, 2, 3, 4. And then the user guesses 1, 0, 5, 7. So note that one digit is correct. Okay. So we would output the number of digits correct. And we would tell them 1. And then we would output the sum of those digits. And in this case, it's just 1, because it's, okay. And we should differentiate here that the digits should be in the correct location. Should we have the digit in the correct location? Okay, we'll have it be in the correct location. So if they put a 1 back here, we'll say it's wrong, or do you want to say it's right? We get to make the rules. Okay, we'll say it's wrong. Okay. We'll make it really hard. Okay. Let's say that they guessed 1, 0, 5, 4. Then the number of digits correct would be 2. And what would be the sum of those digits? 5. Okay? All right. So that we already established that rule that they have to be in the correct position. And then we know what our output should be. So we understand that. So first part of your problem, you understand your specifications totally. You write down your input and output when you're writing these algorithms. I've noticed this thing, especially over here. Here. Cool. Well, it's kind of funny when it's just staring at the wall. It's like, what? All right, so let's write our steps out. Now, I'm not going to put step numbers. Well, I guess we could start with step numbers, but remember, sometimes these numbers change. Okay, because we'll rewrite our algorithm or we'll change it. So I'm just going to put the step number as 0 and then a colon there. All right. So a lot of times what we do in our first step, our 0 step, is just declare some variables. So declare was one of those keywords. So we can think about what variables we'll need in our program, such as, of course, we'll need our secret num. Okay. And he'll be a random secret number. we'll have our user number. Okay, so whatever they guess, or maybe we should call it user guess. That's a better name for him. So our user guess. And then we'll have our sum of digits, our sum of correct digits, we should say. And then our num of correct digits. And I know those are kind of long variable names, but they do read well. Okay, so our sum of correct digits and our num of correct digits. Oh yeah, and then we'll need a variable for their tries, because they only get so many tries. They only get 10 tries to guess this thing, right? That's what our specifications told us. So our game's pretty tough. And then as we need more variables, I don't know if I can think of any, can anybody else think of another one we need? Sometimes you just go on, and then if you need another one, you stick it in there. Okay? So that was our first step, our step 0. And then we think of our next step. Okay? So what do we need to do first? Yeah, we need to create the secret number. Okay? So we can even say that. Create the secret num using random. Now I know that sounds a little bit vague, but most programming languages and things know how to create random numbers, so we'll just assume, hey, we're going to create a random number. And then what will be our next step? Yeah, we're going to get the user guess. Now, we know that you're going to get 10 tries, so we can either write our loop now or write it later. I think it makes sense for a lot of students to write the loop now. Okay, so we can say 4 tries from 1 to 10, something like that. That's kind of common algorithm talk. Okay. So 4 tries from 1 to 10, and then we can put the word do here. And we know this is going to be a sub-step. Okay. And you guys already told me what we should do. We need to get the user guess. Okay, so we can say get user guess from the user, obviously, but we could say from the user. And we can think that that step implies that we're asking the user for the guess. Okay, so we can imply that when we're getting things from the user that we're asking them for it and getting it. Okay, I know some instructors would say, oh, for our algorithm you have to put every single step. But I think assuming that we output something to tell the user to enter is okay. Okay? All right. Next step here. All right. So we get our user guess, and then what do we do with the user guess?
Check.
Yeah, check to see if it's right. We should do that right away, because we don't want to start summing digits and doing all that other stuff if they got it right. If they got it right, we want to tell them they're a winner. So that's a good step to do first. So we know we're going to do a Boolean check, so we could say if our user guess, and we can use some pseudocode here and put an equal sign. Or if you really wanted to, you could even say equal equals. Okay. But if user guess equals our secret num, then, and this will be a sub-step for our if statement, we'll output they're a winner, and end the game. Now again, that some people would debate that that's 2 steps, and it kind of is, but I think that's okay to put that there. Okay. So note that when we output their winner, we don't want to start asking them for more secret numbers, so we do want to end the game right there when we output their winner. Okay? Now if they're not a winner, I mean if they didn't guess it right, then they guess some number. And so what do we need to do? We need to figure out some stuff. We need to figure out how many digits are in the correct place. Okay? And then we need to figure out the sum of those digits. Okay? So we're going to have a little loop here. So we need to figure out each digit individually. Okay? And so we're going to loop 4 times to check each digit individually. Okay? So we can think right now that we are going to have a little for loop. Okay, so 4 digits from 1 to 4. Do this check right here. So we're going to have a for loop within a for loop, which is okay to have. So for digits from 1 to 4, we need to check each digit. They check the digit in the ones place. Or actually, maybe we should pull out the digit in the ones. So we'll make this separate steps. We'll say get the digit in the ones place for our secret num. Okay. And we can store it somewhere. We'll store it in secret digit. Okay. So I know we can do that programmatically, and I'll show you how you can do it programmatically in a lot of programming languages, but that is a step that you can execute in a computer, so that's a good step to have. Okay, you can pull out the ones place inside of a number using the modulus operator. Okay. And then we'll get the ones place out of the other number, the user guess, and call it user digit. So we'll get the digit in the ones place for the secret number. So in that example there, we're getting that 4 out of our secret number 1, 2, 3, 4. And then we'll get the ones place digit out of our user guess, which is the 4 also. Okay, and we're going to store that digit in user digit. So we're going to check the ones place first. We have to do this, in steps. Okay. And then we're going to have an if statement here. So if those 2 digits equal, actually I forgot to change my step number right here. So we'll have an if that secret digit equals the user digit, that means they got that digit right in the ones place. So we need to add it to our digit count. So we'll increment num of correct digits. So that means they got a correct digit. So we say, okay, we'll increment u, set u equal to 1. And then what else do we need to do? Everybody, what do we need to do? Right, good, yes, thank you, yes. We need to add it, add this digit, so add the digit, or actually we should use our variable name since we used them. And you could add secret digit or user digit because they're the same, so you could pick one. Add user digit to sum of correct digits. To remind ourselves that these should start out as 0, we can even up here in our declaration put equals 0, because when we're incrementing or adding things to numbers, they do have to start out as 0. So just to remind ourselves, I just put that little initialize to 0 thing right there. Okay, up in our declarations. Because we're going to increment, and remember to increment something, it has to start out at 0. Right. And summing something, you got to start out at 0. All right. Now what do we need to do? So we got the digit in the ones place. We get the digits in the ones place. We check to see if they're equal. If they are, we increment them. Then we want to get the next digit. But what do we need to do first? We need to get rid of that digit in the ones place so that the 3 and the 5 will be in the ones place in our example here. So our next step in this loop will be to get rid of that ones place digit. And we can do that programmatically. It's actually pretty easy to do. You just divide it by 10. It'll get rid of that number in the ones place. So we can say get rid of the ones place in secret num. And then do the same thing to our user guess. We'll get rid of that ones place. And so then the tens place will become the ones place. So then what we're going to do is we're going to divide it by 10, so then our number now is going to be 123, and our user guess will be 105. And so this will be user guess. Okay, so we get rid of the ones place in secret num, get rid of the ones place in user guess. We're going to come back up to this for loop, get the digit in the ones place, because now the digit in the ones place is the 3 and the 5. We repeat those steps. Then we get rid of the 3 and 5. We get the 2 and the 0 in the ones place. We get the 1 and the 1 in the ones place. And because we rotated 4 times, that'll do that the correct number of times. Okay? So that'll check each of those digits one at a time. Pulling them out of the ones place, checking them, and then get rid of them out of the ones place. Pulling them out of the ones place, checking them, get rid of them out of the ones place. It does that 4 times. Okay? All right. Then what do we need to do after we exit this loop? So after we found the number of correct digits and we found the sum of correct digits, what should we do with those? Yes, output them. Okay, so now that we found our output, we'll output num of correct digits. And again, this could be 2 separate lines, but I'm kind of lazy sometimes, and they're both outputs, so we'll just say output both of those. When we write them in our code, okay, we know that we need to output both. Okay, so we'll output those 2 things. All right, now what are we forgetting here? Oh, we are forgetting something. So we're forgetting something important. Now we wanted to go back up here and loop. But before we get back up there and loop, what should we do to num of correct digits and sum of digits? What should we do right about here? Now we can either do it here or at the beginning of our loop. But we need to do it before we use them again. What do we need to do to them? Yeah, we need to clear them or reset them. So that next time when we get in that for loop, we're not adding new sums to these sums. We want to reset them back to 0. Okay. And if we forgot to write this step in our algorithm, we would have figured it out when we started running this thing. Okay. So we could say reset these variables. Okay. Which pretty much means set them back to 0. So we can even write that to ourselves if we wanted to. Say, okay, we're going to set you back to 0, so then when we start our loop again, you're set back to 0. Yes? Oh, yes. Now, up here in our for loop, we did tries from 1 to 10. So we can kind of assume that tries is being controlled in that for loop and that he's being incremented. When I write an algorithm that has the for and then like a variable name and then 1 to 10, we can assume that he's being incremented each time. Okay? Now if I did write that as a while loop, then yeah, I would want to increment tries. Yes, Jason? Yeah, when we get the new user guess, it'll set that user guess again at the beginning of our loop to the new user guess. Now secret num, we create the outside of our loop so he's staying the same. Oh yeah, so it'll reset when we get to this for loop again. Because the now one thing that we will want to do is we don't want to actually change secret num. So we should make a backup of secret num somewhere, actually. Because we don't want to start getting rid of the digits in secret num. We don't really care about user guess because he gets reset. But secret num we need to keep, you know, great. So, actually right about here, let's put a step in here. And we'll say make a copy of secret num. So that way we're not actually changing secret num. And we could call that copy of secret num. So actually that was a good point, Jason. Yeah, we don't want to change secret num. We can change user guess, but secret num we want to keep it the same so that way when we go play the second time around he's not gone. And then we'll manipulate the copy of secret num and not secret num in our little for loop here. So when it says get the digit in the ones place for copy of the secret num, and then get rid of the ones place in copy of secret num. So that way we're not actually editing our secret num. So we can think of that up ahead too in our algorithm. So when we start getting rid of those digits, they are going to get rid of them in memory. And they are going to manipulate the numbers, so we don't want to totally erase secret num there. We want to keep him. Okay. All right. Now if we ever exit this for loop, there's one way we can exit it. If they get the user guess, we end the game right here. Another way that they can exit this for loop is if tries equals 10. Then we're going to leave this for loop. Now if tries equals 10 and we leave the for loop, what does that mean? What does that mean? If we exit this for loop and they did not, there's one way that we've already exited the for loop. We output winner and end the game. If we go all the tries and we never get here, what does that mean? Losers. Yeah, they're a loser. That means they lost. Doesn't mean they're a total loser. It just means they lost the game, right? They're yeah, then we output something. We say output, haha, I won, or output, you lost, or output something. And then you can end the game.
Put game over?
Yeah, you can put game over, try again next time, better luck, something to that effect. Okay. We try not to be too rude. But yeah. It is a hard game. You can try playing it with yourself without giving yourself the secret num and see how many times you actually win. And then we can cheat and output the secret num to test it, of course, but then we have to get rid of that cheat code, right? All right. Yeah, we can even make a little cheat, so if they push the letter C, maybe it shows them the secret num. A little cheat code in there. Okay. So now we have our algorithm. This is actually the algorithm. Now there's many ways you could have written this, but this is one way that we wrote it, and this way it'll work. Okay. So now all we have to do is follow our algorithm. In our algorithm, we wrote it in such a way that each line equates to 1 or 2 lines of code. Okay, so we should be able to write this thing, no problem. I debated whether to make all of you guys write it, or maybe we could just... Actually, I think that's a good idea. So instead of you guys just copying me, what I'm going to have you guys do, and you can work in pairs together, is I'm going to have you guys program it. Okay? Yes. And you can work in programming pairs. So if you want to work in a programming pair, that means you can work with one other person and program it together. Okay. Each line of code should equate to 1 or 2 lines of code. The only ones that are 1 or 2 are like this one right here would equate to 2 lines of code. All right, but let me show you just kind of the pseudocode for getting the digit in the ones place. Okay, so if you guys want to write down the pseudocode, this would be how you get the digit in the ones place, because this part is a little bit trickier if you don't know, how to get a digit out of a ones place in a programming language. So I'll actually write the code right here for this part. So okay. So I'll show you. Okay, so you would say, okay, your digit equals, if you modulus this guy by 10, it will pull out that ones place digit. If you divide any number by 10, what's the remainder? 1,006 divided by 10, what's the remainder? 6. 1,500,012. What's the remainder if I divide it by 10? 2. 54 divided by 10. What's the remainder in ones place? 4. It's always the ones place. So when you modulus something by 10, it gives you the ones place. Okay, so that's a cool way to get the ones place out of a number, is you modulus it by 10. Any number modulus by 10 will give you that number in the ones place. Okay, so you would just do the same thing for secret digit. Okay. Oh wait, we called it secret digit. Sorry, I made up my name wrong. Hold on. So we named it secret digit right here in our algorithm, so I'm going to name it secret digit right here. Secret digit equals that copy of my secret num modulus by 10. Okay, and then when you get the digit for the ones place in user guess, you would use that same methodology of modulusing by 10. Now get rid of the ones place in secret num. Okay, I'll write some pseudocode for this. To get rid of the ones place in any kind of number, now you can write it this way, or remember that you can condense it and write it this way. All right. So what happens if I divide 1, 2, 3, 4 by 10? What number will I get? If you divide something by 10, what does it do? It moves the decimal place up 1. It gets rid of the ones place. So if I divide an integer by an integer, it'll move that decimal place up 1 and drop all the decimals, and now I have an integer without the ones place. So that's how you get rid of the ones place in an integer, is you just divide it by 10. Okay? So here we get the ones place out, we extract it and hold it, and then here we get rid of it completely. We get it out of the number by dividing by 10. Okay, so that's your pseudocode for those two parts. Now adding and incrementing, you guys should know how to do all those. For your for loop, you should know how to do your for loops. Your output and your reset, you should know how to do. So those were the two tricky parts of this one. The coding parts. All right? So what I'm going to do is I'm going to have you guys write this today. This is your class assignment. You will turn it in. You can turn it in as a pair. So if you do work in programming pairs, you have the option of working in programming pairs or working on your own. Okay? So if you do work in a pair, only one of you needs to turn it in, and you put both your names on the top. Okay? Otherwise, you could work on your own. That's fine too. But you have all of your algorithm here. So you would just translate each of these lines to a line of programming code, which I'm sure all of you can do. And then I'll come around, and if you get syntax errors, we'll fix them. But I think this is a good exercise. Okay? So everybody knows what we were doing. And then after you finish, you will turn it into Blackboard. okay? All right, everyone's clear? Any questions? All right, so let me pause this.